In this tutorial, I'm going to demonstrate how to run a permutation test to compare two proportions using the functionality found in the Mosaic package in R. We'll also plot the randomization distribution using functionality found in ggplot2. So I've already loaded in the two packages that I've highlighted here, as well as my data set, which I downloaded and put in my data folder. So you should do that before proceeding. Once you're there, what you can do is check that the data set read in correctly just by looking at the first 6 rows. And what you're going to see is that we have 2 columns in our data set. The first column here specifies the drug that was given to each subject. The example consists of 48 subjects that were either given dicipramine or lithium to treat cocaine addiction. The researchers were interested in comparing the proportion of folks who relapsed, and so the other column records whether or not the individual relapsed during the trial period. You can also click Run and look at Summary just to get a basic breakdown to see how many people were in each treatment group, as well as how many people relapsed overall. But what we are really interested in is understanding how the relapses break down by drug. And so the Mosaic package has a function called tally, which will do just that. So I'll highlight this tally command and click Run, and what you'll see is that this gives us a very quick two-way table where we see each individual, an aggregation of all the individual subjects into either yes or no by relapse, as well as what drug treatment group they were in. Now what we want to do is understand how the proportions differ. And so what we could do is look at the proportion of folks who do relapse and compare that. In order to compare that, what we would do is calculate a sample proportion for the zippering group, which would be 10 divided by 24, which is the first column total. For the lithium group, we would do 18 divided by 24, and we could subtract that. But we would like to automate this and see what happens. So, looking at this, we have our two-way table, and we'd like to automate it. So if we go down to line 20 of my code and change the relapse to yes, we can do just this. Now let's just run the first piece of code to see what type of output we can expect. And so what we will see here is that we expect to obtain this difference in proportions. And it will be the second group minus the first. So if you look at the two-way table, lithium will be the second group. Dicipramine will be the first. And the notation here is a little different than what we've used before. Specifically, you'd probably be expecting to calculate a difference of proportions, and the function name here is diffmean for difference of means. Well, what we're actually doing is taking the average for each of these groups of a string of zeros and ones. So let's talk through that. For each group, that's why it's tilde drug in the formula. For each group, we're calculating relapse equal yes. And so what this does is take the relapse column and say either true or false for whether or not someone relapsed. If it's true that someone relapsed, that will be written down as a 1. If it's false that someone relapsed, then it will be written down as a 0. And so when we take the mean of 1s and 0s, what we're doing is adding up the number of 1s, dividing by the total number of observations in that group. And so we're getting a proportion out using a mean. And that's exactly what we want here. And so let's store that as our observed statistic, and you'll see that, okay, we have our expected mean difference, or difference of means, of 0.33. Now what we need to do is, and I need to line everything up so it's yes, to be consistent with what we did in class. So now that's consistent. And what we see here is that we need to use this shuffle again. So we want to break the potential dependence between relapse and the drug that was assigned to someone. And so what we're going to do is shuffle that drug column and then calculate this mean again. So let's see what's going on here. For one iteration, what this will do is shuffle the drug column of that data set and then report the two means. And then we'll use diff to take the difference. Now, let's do that again, but actually find the difference. It'll be a different value this time because it's a different shuffling. So what we'll see is that we get negative 0.083 this time. Okay, now we'd like to do this 1,000 times, so we're going to use the do command in the Mosaic package. We're going to do this diff mean function 1,000 times and store that as cocaine underscore null for the null distribution or the randomization distribution. Now let's take a look at what the first 6 rows look like by running the head on that. And so we see that we just get a string of differences of means. Now we can plot the randomization distribution by simply creating a histogram from this data frame. And let's do that real quick. And we'll see that our randomization distribution pops up. It looks roughly as we expect. You can also superimpose a line indicating the observed sample proportion. Now let's type in observed again to see what we expect. Well, that should be at 0.33 or so. We'll run this code again, and we can see that the vertical line does give us the observed proportion. Now we need to calculate a p-value. And the researchers believed that the new drug, zippering, would be more effective at treating cocaine addiction, so there would be fewer relapses. Now, if you remember the order of the differences, it was lithium, the proportion of relapses in lithium minus the proportion of relapses in zippering. So there should be fewer relapses in the zippering treatment group if the drug is effective. So we'd expect this difference to be larger. So it is a right-tailed p-value. So we need to, down here, do prop to calculate the proportion of the differences of means that are greater than or equal to the observed value in our null distribution. And what we see in this set of 1,000 simulated values is that we would observe a difference of proportions of 0.33 or so, approximately 1.7% of the time by chance alone. Now you should be able to think to yourself what that means and to make a conclusion or draw a conclusion. So this is how you create a randomization distribution and calculate an associated p-value for a permutation test or randomization test comparing two proportions.